Hi, welcome you once again. In this session, we are going to use the vector class to implement the list interface in Java collections. Vector is using the dynamic array structure to store the array of objects. For example, when you are creating the object by using the vector class, it will create the array with some number of memory locations. Vector, not array, vector, but the form look like a array structure. Okay, so here the vector is created, for example, with the number of memory locations here, which is storing the object 1, object 2, object 3, etc. So here, whenever we are creating the vector, it will be look like identical to the array list during the implementation. Then what is the difference between a vector and array list? Here, whenever the elements inside the vector is exceeding its capacity, that means here the capacity of the vector is 4. Okay, so now I am storing the objects one by one: object 1, object 2, object 3, object 4. Now I want to store the object 5. Okay, so in this circumstance, the vector size is not sufficient to store this fifth object. At that time, automatically the length of the array will be increased 100%. Here 4 is the 100 percentage of memory locations, so 4 more memory locations will be created, I mean added to the existing vector. So now fourth memory location, fifth, sixth, seventh. So now totally the size of the vector is increased into the 8. So 100 percentage is increased, that is doubling the current vector size. That means which is looking like a array structure, dynamic array. That's what I mentioned here, array size. But in array list implementation, when the array is not sufficient, then it will increase only the 50% of the total size of the array memory locations. That is the difference between the vector and array list. So if you use the array list, so if it is having 4 memory location at the initial stage, then it will add 2 more memory locations, that is the 50 percentage of this 4 memory location, right? So that is the difference here. Then based upon this, here we are going to see the performance of the vector, yeah, right, which is very slow because which is synchronized, but array list is very fast when comparing to the vector implementation because it is not synchronized. The synchronization in the sense, the thread concept will come into the picture. Thread 1 is accessing the array list variable and thread 2 is also accessing the array list variable. So both are performing concurrently, that means parallelly. So when thread 1 is accessing this array list, thread 2 is also accessing, thread 3 is also accessing, etc. So now thread 1 may change the variable, I mean object value, right, variable value in the objects. So at that time thread 2 may access this object. So here the synchronization, mutual exclusion is not possible here, so synchronization is not achieved here. So the modified value will be passing into the thread 2 and thread 3, etc. So which is very faster. But in vector, you see, when thread 1 is accessing the object of the vector, other threads are waiting in the queue. This is thread waiting queue. In that waiting queue, remaining threads are waiting until completion of the thread 1 work. So after completion of the thread 1, then only thread 2 will enter into the vector, right? After completion of the thread 2, then thread 3 will enter. So one by one it will enter into the process, then perform the operations. So it is very slow comparing to the array list based implementation. In array list here, which is performing better when we are having single thread in the environment. So for example, if it is having only single thread, then array list is giving better performance than the vector based implementation in the list interface, right? So which is preventing the concurrent access is used, right? Because the remaining threads are in the waiting queue when a thread is accessing the object at current situation, but here all threads are accessing the object parallelly at the same time. So here, which is not preventing the concurrent access, but here which is preventing the parallel access of the threads. Here we are seeing the example which is implementing the list interface by using vector class is creating the object small v, right, by using the string data type wrapper class data type. Once this is executed, then this structure will create with some memory locations. Then I am performing the adding operation, right, which is storing the value soy in the variable v. Then next statement is adding the Srinivas in the second memory location of the vector structure. Then Pavan is added here in the vector structure. Now v is having three elements. Then that v content is transferring to the itr variable, which is created by using the iterator class, then which is implementing the iterator interface, which is using the iterator method. Iterator method is here to move from one element to another element iteratively, right? So now the itr is having this structure. Then it is checking itr is having the element, yes, itr is having the next element, then which is returning true here. Then here which is printing the value, right, current value is soy, right, this one printed. Then it is moving to the next element in the vector structure, right? Then which is available here, itr is now available here. Then next statement is not there. Going back to the while condition, now it is checking itr as next, yes, itr is having the next element which is returning true. Then getting inside the while loop, which is printing the current element of the itr. So current element of the itr is Srinivas, so Srinivas is printed here. Then moving to the next element, so next element is Pavan. Then again going back to the while loop, so now itr has next, yes, itr is having next element, so which is returning true. Then printing the current element itr, so Pavan is the value which is printing. Then moving to the next value, so next value here is null. So now itr is having the null, so which is checking has next. So here null not, yeah, valid value, so it will return false. Once it is returning false, it will not enter into the while loop, come out of the while loop, so there is no statements after that. Then it will come out of the program execution. So like this, here we can add the elements and display the elements by using the vector class. And if you want to perform any other operations here, you can perform in this program by based upon the problem statement is given to you. And the next one is here we are going to use the integer wrapper class. The previous one is string wrapper class. Here vector is the class we are using to implement the list interface. V is the vector variable. Once it is executing the statement, then this structure will create with some memory locations. Then here I am using the for loop to add the elements one by one, adding the I value. So I value is 101, adding into the structure, so 101 is added. Then again going back, I is incremented by 1, so 102 less than or equal to 105, then it is true. Then get inside the for loop, so in the for loop we are adding the next element 102, so 102 is added here. Then again going back 103 by incrementing the I, so now 103 is also less than or equal to 105, then which is entering here. 103 is added into the V. Then here 104, right, 104 also less than or equal to 105, then entering into the for loop, adding the I value is 104, 104 is added into the V. Then I is incremented, so now 105, so 105 also less than or equal to 105, then here which is adding into the v, but here v is not having the sufficient memory location. So what will be happen, it will double the memory locations, it will create 100 percentage of memory locations by incrementing that. So now here it is adding 4 more memory locations, right? Totally now 8 memory locations are there, then 105 is added here, then again I is incremented, so 106, 106 less than or equal to 105 is false, it will come out of the loop. Now you see, this is the structure of the v. Now we are printing that structure here, that is the structure we are printing here. So now the data which are available in the v is printing 101, 102, 103, 104, 105. The index will be written like 0, 1, 2, 3, 4, 5, 6, 7, right? Now the removing operation is performing at the index number 3 is removing the element. So index number 3 we are having 104, so 104 is removing. After removing that, the structure of the v, right, we are going to display. So after removing this, right, we are having only 4 elements, 101, 102, 103 and 105, just displaying this. Here we are performing two operations, one is adding and another one is removing the element from the vector structure. Here we are implementing the list interface by using vector class. And another one example, here I am using the user defined input by using the scanner class. Once the vector is creating the object, then that structure will be created like this, with some memory location to implement the interface. Then enter the number of inputs, right? So here enter the number of inputs, the number of inputs is the integer value, next int by using the scanner input. So here 5 is the n value, then enter the integers as input, this statement is displaying. Then here for loop is used to get the input I equal to 1 to n value is here 5, so 5 is the n value. Then we are adding by receiving the input from the scanner class object, next int, first input we are receiving, that is here 100. Okay, so 100 is added here, then this is the v, right? Then next one is I is incremented, so I equal to 2, so 2 less than or equal to 5, so again entering the for loop. So now I am receiving the element 200, so 200 is added, then again I is incremented, so 3 less than or equal to 5, it is true, so again get inside the for loop, receiving next input 300, so 300 is added into the v. Then again I is incremented, so I value is 4 less than or equal to 5, so it is true, then again entered into the for loop, receiving the next integer input 400, so 400 is added into the v. Then again I is incremented, so I value is 5 less than or equal to 5 now, which is again true, so enter into the for loop, receiving the next input 500 and adding into the v. But here v is not having any more memory locations, it is having only 4 memory locations. So now it is going to increment the vector size into double 100%, so it is going to add 4 more. Okay, this is extension. Okay, extension of 4 more memory locations, so fourth memory location, fifth memory location, sixth, seventh memory location, totally 8 memory locations. So now the after incrementing that, the fifth element is 500, which is going to add at the index number 4, that is the fifth position. Okay, then again I is incremented, 6 less than or equal to 5, which is false, then it will come out of the for loop. After for loop, just we are displaying the values which are stored in the v, so that displaying the elements are 100, 200, 300, 400, 500, which are stored in the v. Then I am displaying the values, enter the integers index to delete, that should be less than the n value. N value is here 5. Okay, so n value here we have entered as a 5 here, that should be less than 5. As of this, I am receiving the input from the user 3. 3 is the index, right? Whatever value available at the index number 3, I'm going to remove. So index number 3, here I'm having the value is 400, right? The 400 is removed. After removing that, my structure of the vector is 100, 200, 300, 500. So that is displaying by using the statement this one. Then program is completed here. So this is the way to add and remove the elements based upon the scanner class. Thanks for watching.